to be here with you again as we dive into our series with regards to physics, jam preparation as we have it. So, today we're going to be analyzing questions once again in our bid to achieve excellence come March or April of 2025 in our examinations. Now, here is how we're going to go about it. In order to achieve this excellence, we'll be focusing our revision series for today will be focused on the following, looking at questions from the various branches of physics. So let's get right into it. The first will be with regards to question on mechanics. Number one, mechanics. So the first question of the day with regards to mechanics would be this. In the diagram below, which of the simple pendulum? In the diagram below, which of the simple pendulum will resonate with P when set in oscillation? Question mark. And the diagram is this. The first, we have P at this level. The next, we have Q at this level. The next, we have R at this level. The next, we have S at this level. And we have T at this level. Not forgetting, we have U at this level. P, Q, R, S, T. So, under simple pendulum, there are key things we look out for with regards to this question under simple pendulum. So, we'll be looking at that as we proceed. When a question like this is asking us to figure out which of the pendulum will resonate with what? P. It means that what? Which of these will vibrate at the same frequency with bulb P when set in motion. And we've identified among the things we know under simple pendulum that period of oscillation is such that you have 2 pi square root of L over G, where L is the length of the simple pendulum. Similarly, we have that the frequency which we are going to have for the oscillating body is going to be equal to 1 over period. And as such, we can easily phantom that what? The length will be a subject factor of resonance. The length is going to be a subject factor of resonance. Therefore, we can only have, note, we can only have a body at resonance when it is set in vibration by another body having the same frequency. Now, both of them are expected to share the same frequency, subject to the what? Resonance. For this guy Q, for the fact that it has a longer length, it can never be set in motion as a result of P. Similarly, R has a shorter what? Length. Hence, it cannot be what? Set in motion. It cannot be set in resonance with what? P. Not forgetting S. The bulb S can never be set into what? Into oscillation as a result of what? The oscillation of P. Why? It has a longer length. Only C, which has the same length. Well, this is a freehand sketch. So some of you might want to argue, oh, they don't look exactly alike. Please, this is just a freehand sketch. We have it such that what? P and T are of the same length based on the question. It is only what? Objects that have the same length that can be set into what? Resonance with each other. So we say that what? Answer would be that only what? Only T would be the answer. Only T would be the what? Answer. Have that at the back of your mind. Mechanics. Another question under mechanics, we look at it. Another question with regards to mechanics, we're given this. So here is it. We are told this. A simple pendulum actually has a pulley system. We are going to be dealing with diagrams today. Here is the hook. Here are the extensions. So we have 1, 2, 3. Then we have 1, 2, then 3. Such that this guy moves through this point, through this point, through this point here. And we have this part as 80 Newton. We have a hook. This part as 240 Newton. So look at this. We are told that an effort of 80 Newton is used to lift a load of 240 Newton. Find the efficiency. So this is the question before us. We are to calculate the efficiency of this pulley system. A system whereby we have some set of connection of pulley and we have a load that is about to be overcome. 240 Newton is the value of the load. The effort used is actually what? 80 Newton. And this brings to bear the formula we have as far as pulley system is concerned, where we are told that what? The velocity ratio of a pulley system or a block and tackle system is just the number of pulleys. Number of pulleys present. The velocity ratio is just the number of pulleys. So it means that what? We are to count how many pulleys we have in this system. And going by the count, we have 1, we have 2, we have 3, we have 4, we have 5, and we have 6. It means the velocity ratio here is equal to 6. Not forgetting, load and effort is embedded under a formula known as mechanical advantage. So the mechanical advantage MA, as we write it, for this system is derived using the formula load over effort. Load over effort. Therefore, mechanical advantage becomes 240 over 80. 240 over 80 giving us 3. We have our velocity ratio. We have our mechanical advantage. How do we combine both together to arrive at our final destination, which is the efficiency of the pulley system? All we have to do is simply take the ratio of what? Mechanical advantage to the velocity ratio multiplied by 100. This is what I mean. We say efficiency is equal to MA over VR times 100. And this gives us what? 3 over 6 multiplied by 100. And here we have 50% as the value we want to get. 50% as the value we want to get. But quickly, we won't stop here to identify the fact that what? Velocity ratios are actually different for various machines. Various machines which Jamb will ask you would have their own velocity ratio. So take into account that if we are dealing with velocity ratio of a gear system, so the gear system, we say VR is equal to number of teeth of driven gear over number of teeth of driving gear. Or we say speed of driving gear over speed of driven gear. So what do we mean by this? When you have two gear systems, this and we have a bigger one. Here, it is such that when we have a mechanism that binds them together, it's expected that when you are to count the number of teeth of the bigger gear, it's going to have a bigger number of teeth compared to the what? Smaller one. The smaller one is the driving, the bigger one is the driven. So as such, the smaller one is driving the bigger one. It's going to have what? A lesser number of teeth compared to the driven one. That's why we have the number of teeth of the driven on top of the driving. Note the bigger value on top of the smaller value. But with regards to the speed, the smaller one is faster than what? The bigger one. The driving gear has more speed than the what? Driven gear. You can talk about a screw. The VR for a screw is given as 2 pi r over pitch. 2 pi r over pitch. Similarly, when we make reference to an inclined plane, you have the velocity ratio is simply 1 over sine theta. Or we are saying velocity ratio is distance moved by load by effort over distance moved by load. So there we have it over there. Distance moved by effort divided by distance moved by load. Or you are using 1 over sine theta. You have this at the velocity ratio for other types of machine which you can encounter in your examination. So that settles it. Under mechanics, we've looked at 2 questions. One under simple pendulum, the other under simple machines. So simple pendulum, simple machines. There we've been able to look at what? Questions with regards to them. Quickly, we move to the next aspect of physics, which is now going to be under heat and temperature. Under heat and temperature. So let's go for it. Heat and temperature. heat and temperature. We're told this. The other branch of physics, heat and temperature. The first question says this: ice cubes are added to a glass of warm water. Are added to a glass of warm water. Full stop. The glass and water are cooled by what process? A, you have conduction only. B, you have convection only. C, you have conduction and convection. D, you have convection and radiation. So that's for the next question. That's for the next question, non-calculation. We are told that ice cubes are added to a glass of warm water, and the glass and the water are both what? Are cooled. The glass and the water are cooled by what means? Is it conduction alone? Is it convection only? Is it conduction and convection process, or is it convection and radiation? So to understand this concept, we have to first know exactly what is conduction, what is convection, what is radiation. Conduction involves the transfer of heat from one point of a material to another by what? The movement of the electrons. You have that by moving of heat from one point to another is the transfer of heat from one point to another in a material, usually what? Conductors, usually metals, usually materials that can what? Conduct heat. Now, you have that there is no permanent displacement or shift in what? In the composition of such materials. That's why you have wooden materials would not be tagged conductors. Why? They cannot what? Allow it to flow from one part on them to another. It cannot flow from one part of what? A wooden material to another part. So here we go. Conduction, it's been transferred from one point of what? A conducting material to another point. When we make reference to what? When we make reference to convection, we say convection process is the form of heat transfer as a result of the mass movement of the fluid. It involves the what? Movement of what? Heat. As a result of what? Is the transfer of heat as a result of the mass movement of what? Of the fluid. The fluid has to move entirely. Now, when we make reference to radiation, it's the transfer of heat without what? An intervening medium. Heat is transferred from one body to another without any intervening medium in between. So having this been cleared out, conduction in this context, can it work? It's a question to ask. We have the ice cube in contact with what? The water. Then, with regards to what? With regards to the convection process, mass movement of heat. But remember, the question is talking about the cooling effect of the warm water. The cooling effect of the warm water. So here is it. We are going to take it as what? The process by which these two guys, the glass, note, the glass and the water will be cooled down, will be such that what? Convection for the liquid, which is the water, and conduction for the glass. Convection for the what? Liquid, which is the water, and conduction for the glass, which is solid. Convection does not take place in solid. Note that. Convection does not take place in solid. Conduction does not take place in solid. As such, convection does not take place in solid. Only conduction takes place in solid. Similarly, for the water, it is convection process that takes place. As such, it can't be only convection, it can't be only conduction. It has to be what? Both of them together. It has to be what? Both of them together. In this case of what? Cooling down of the water by the ice cube. That process has to take place by two processes. One conduction, the other convection. I said that again. The conduction process does not take place in liquid. Here, we are having it take place in the what? Glass. The water convection process takes place in it. Let me bring to bear that what? There are various examples you will find, and among them, talking about land and sea breeze. What else are you going to be asked under this aspect? Land and sea breeze. And this is what? A convection process. Land and sea breeze, convection process. Land breeze. Land breeze would occur at night. Land breeze would occur at night, and it involves land to sea. Land to sea. Sea breeze during the day, and it involves sea breeze towards the land. Have that at the back of your mind. And the key concept, all this now, talking about, cool breeze blows from the sea to the land during the day. At night, cool breeze from the land blows towards the sea at night. All these are still layman terms. In physics, note, in physics, your Jamb preparation, have it at the back of your mind that what? These two guys here, we deal with specific heat capacity that they possess. What is specific heat capacity? We are talking about what? The amount of energy that is what? Is talking about the temperature, the amount of energy that is actually required to raise the temperature of this substance, a unit mass of the substance, by 1 what? Kelvin. The amount of energy needed to raise the temperature of what? This substance, in this case now, considering the land or considering the sea, to raise the temperature of land or to raise the temperature of sea through 1 Kelvin. So that's the specific heat capacity. It is specific heat capacity that alters this change. The specific heat capacity of the two of them. The sea has a larger specific heat capacity than land. So it takes long time to lose its heat. Have that at the back of your mind. Heat and temperature, don't forget. The next question under this part, still under heat and temperature. Remember, it's better you face your fear now. You are not under pressure at any point.